Okay, we'll look at some of the homework problems in section 11.3 where we're dealing with polygons. And in this case, problem number 1, you want to determine which of the figures is a polygon. And keep in mind, a polygon, it has to be a closed figure with no holes in it. And in this case here, the only ones that would fit this description would be number 3, because that's a closed figure with no holes in it, and figure number 4. Those two are polygons. So only number 3 and number 4 are polygons. Number 1 is not because it has a hole in it. The same with number 2. Number 5 has a break in between those, and number 6 has a straight line in it. Okay, so it has a straight line in between those two. So those would not qualify as polygons. It has to be a closed figure with a starting point and an end point as well. Problem number 2. Describe whether the figure is convex or concave. Okay. Convex has no indentations in it, whereas a concave polygon does have indentations. This one does not have indentations because concave is something that's caved in, as I would say. So in this case here, this figure is convex. Okay, because I can draw a point here and a point here, and that line segment is wholly contained inside that polygon. Okay. Problem number 3. Classify the triangle W, which is this figure right here. Here's figure W right here. Triangle W is either equilateral, isosceles, or scalene. By definition, a scalene triangle is a triangle where none of the sides have equal measures. Like V has different lengths for each side. So that's a scalene triangle. An equilateral triangle would be something like Y. Each side is the same. But here we're classifying triangle W. So here's W right here. Notice that these two sides are the same. That's an isosceles triangle. So triangle W, is an isosceles triangle. Problem number 4. Find the lines of symmetry, if any, for the figure at the right. So here you have an arrow going this way. Now, keep in mind, lines of symmetry is going to be those lines that will separate this particular figure in a way that the left side has the mirror image of the right side. And the only one that would fit that would be B. Because if you draw a horizontal line going through the middle of that arrow, the left side of the arrow has the mirror image of the right side of the arrow. So just be answer B in this case. Problem number 5. Classify the polygons shown at the right. Okay, so here's a polygon, 4-sided figure. Now notice in this case here, you have 2 adjacent sides that are congruent and another pair of adjacent sides that are congruent to each other. So in this case, this would classify, if you recall, a kite. Because the definition of a kite is a quadrilateral where the 2 adjacent sides are congruent and another pair of adjacent sides that are congruent as well. So here is a kite, but not rhombus. Okay, problem number 6. A pentagon has only 2 diagonals that intersect at a given vertex. Determine how many diagonals intersect at a given vertex in each of the following polygons. Okay, so here we can draw some things, like in part A, the number of diagonals that intersect a given vertex of a triangle. And in this case here, I'll go ahead and draw a triangle. This is what a triangle looks like. Because you want diagonals that's going to intersect a given vertex. This diagonal will not be able to intersect any of the other two vertices, because you can't use this to intersect this because that's the side, and you can't use this vertex to intersect the other to come up with another vertex to form a diagonal. So in this case here, in a triangle, there's 0 diagonals. Number 2, part B, the number of diagonals that intersect at a given vertex of a heptagon. Okay, in a heptagon, there are 7 sides. So here we've got 1, 2, 3, 4, 5, 6, 7. Not the best, but it will work. Okay, a diagonal is going to intersect 2 non-adjacent vertices. This vertex and this vertex forms a diagonal. The same vertex and this other vertex forms another diagonal. This vertex with the same vertex forms a third, and this one with this one forms a fourth. So in this case here, I have 4 diagonals. And keep in mind, a heptagon is 7 sides. It's a 7-sided figure. Okay. Now, the number of diagonals that intersect a given vertex of a 20gon is what? Okay, let's do a little bit of intuitive thinking here. The number of sides and the number of diagonals, I want to compare that. The number of diagonals here, the difference between the number of sides of the heptagon and the number of diagonals is 3. Okay, that's the difference between those two. So, to get the number of diagonals, you take the number of sides minus 3 to get the number of diagonals. Okay, so in this case here, for a 20gon, the number of diagonals in a 20gon is going to be 20 minus 3, which is 17. So there's 17 diagonals in a 20gon. And of course, part D is the one that I just gave you here. The number of diagonals that intersect a given vertex of an n-gon of any polygon, that's n minus 3. That's always the number of sides of that particular polygon minus 3. And you can look at this particular situation here with the heptagon, where I have 7 sides in the heptagon, and I came up with 4 diagonals. So the difference between the number of sides and the number of diagonals is always 3. So to get the number of diagonals, you always subtract 3 from the number of sides. So here, the number of diagonals in a n-gon that can be intersected at any given vertex is n minus 3. And that should assist you with some of the homework problems in section 11.3.